Ever since the ancient Sumerians and Egyptians, aspirin has been used to treat pain and fever by reducing inflammation. Let's explore this compound's history and properties. The ancient Sumerians, Egyptians, and even Greeks found that eating bark scraped off a willow tree reduced pain and inflammation. Here's a timeline. In 1763, Edward Stone successfully treated malaria patients with grinded willow bark. Later in 1828, Johann Buchner purified the substance from willow bark and called it salicin, Latin for willow. Finally, in 1897, Felix Hoffmann synthesized acetylsalicylic acid at the Bayer Company. As the first artificially synthesized drug, aspirin marked the beginning of the pharmaceutical industry. Bayer's aspirin had widespread success due to its anti-inflammatory and fever-reducing properties. In the body, aspirin inhibits the production of thromboxanes, which cause platelets to aggregate and clot the blood, thereby stopping blood clots. By stopping blood clots, aspirin can prevent dangerous strokes and heart attacks. Unfortunately, aspirin can cause unwanted gastrointestinal bleeding by destroying the stomach lining. An overdose can cause Ray's syndrome, especially in children, so do not take aspirin unless your doctor tells you to. The NIH recommends aspirin be used by men aged 45 to 79 and women aged 55 to 79 when its benefits against heart attack and cancer outweigh its risk of causing gastrointestinal bleeding. In other words, older people with a risk of heart problems. Specifically, COX-1 enzymes envelop the arachidonic acid, turning it into prostaglandin H2. Prostaglandin H2 then turns into thromboxane A2, which signals platelets to clot the blood. Aspirin closes off the COX-1 enzyme permanently so that the prostaglandin H2 cannot go in and turn into thromboxane. However, new COX-1 enzymes are constantly being produced, so many elderly consume the small baby dose of 81 milligrams daily to intercept the new COX-1 enzymes. Since aspirin is absorbed into the system quickly, the bigger adult dose of 325 milligrams is used when someone is experiencing a heart attack to quickly break the clot. Aspirin prevents platelets from clotting, so one of the side effects is bleeding. Let's talk about aspirin's chemical properties and how they relate on the molecular level.
In this 3D model, blue is oxygen, yellow is carbon, green is hydrogen. The orange sticks represent double bonds, while the thinner white sticks represent single bonds. Let's take a look at the polarity. As you can see, aspirin is not symmetrical, veers off to the left this way, and the hydroxyl here is also sticking out, and this causes it to be polar. Because it is polar, it is soluble, and due to its solubility, aspirin pills are enteric coated, so the aspirin does not dissolve in the stomach and instead passes to the small intestines. In terms of intermolecular forces, the molecule's polarity causes dipole-dipole forces, and the oxygen and hydrogens cause hydrogen bonding. And of course, like with any big molecule, London dispersion forces are present. The strength of the intermolecular forces causes aspirin to have a melting point at 136 degrees Celsius.
Throughout history, aspirin has been consumed and its usage has evolved. In ancient times, it started as a pain reliever. Its particular shape and charge makes it lock into catalysts, preventing enzymes from entering. This principle explains both the pain-killing and anti-clotting effects of aspirin. Nowadays, it is used to reduce the risk of strokes and heart attacks from blood clots in older people who are vulnerable. Additionally, its anti-inflammation properties make it useful in treating rheumatism, inflammation in the joints, and Kawasaki disease in children under age 5. As of 2020, 40,000 tons of aspirin are produced in the world annually, with 43 million Americans taking aspirin daily. Now, we are discovering that it also helps reduce the chances of colorectal and gastrointestinal cancer. Harvard's JAMA Oncology study concluded that using aspirin for 6 years or longer reduces colorectal cancer risk by 19% and gastrointestinal cancer by 15%. And that's the history and chemistry of this compound in a nutshell. Scientists continue to research this compound, so we shall see more applications in the future.